So hi everyone. I wanted to talk today a little bit about the connection between elements of a group as actions and elements of a group as things that do binary operations. So I'm going to start by writing out a Cayley diagram. And if you want to follow along with me, you can start to write out the Cayley diagram of the mod 5 group under multiplication. And let's say that we have the generator times 3. Okay, so if we think about mod 5, and then the elements that can be multiplied. We have everything except for 0. Everything except for 0 in mod 5 can be multiplied. So that's going to be 1, our identity, 2, 3, and 4. And remember that 5 is equivalent to 0 modulo 5. So that is not in our multiplication group. So to understand where we might want to start when we draw our Cayley diagram, well, I always start with the identity. So we'll always start with the number 1. And let's consider the generator, which is times 3. So when we multiply by 3, well, we'll obviously get 3. 1 times 3 is 3. And when we multiply by 3 again, we're doing an action on 3, right? We're doing this 3 is acting on this 3 element here. Okay, and so 3 times 3, well, under normal arithmetic, that's equal to 9, and 9 is equal to 4 modulo 5, so we end up with the 4 there. And then if we want to do times 3 again, now we have 3 is acting on 4. Let me write that out. So here 3 is acting on 4. Okay, so we get 12, which is equivalent to 2 modulo 5. And then times 3 again. Now we have 3 acting on 2. 3 is doing something to 2. It's being multiplied by 2. So 3 times 2 is 6, which is equivalent to 1 modulo 5. So actually we end up right at the beginning. So I'm going to just extend that arrow. And we end up at the beginning. So we have 2 perspectives we can take with this multiplication. The first one is an action. That 3 is acting on other numbers. And when we have a Cayley diagram, I think we really see this because we have arrows and I don't know, somehow that acting is really clear. 3 is a generator of this group as well. So that action is really emphasized by these arrows. We also have another perspective, which happens when I just think about my computations, right? So for example, here in the last one, I have 2 times 3. That's a binary operation because the generators of the group are also members of the group. This 3 is actually taking place in a circle on the group. So when we are doing an operation to get an arrow, we have a binary operation. This just means an operation involving 2 elements. We see this more when we think about 3 as an element of the group. I want to further emphasize this point by talking about different ways we can compute things in groups, different ways that we can figure out the result of binary operations in groups. So if I want to figure out what the result of, well, let's say 3 times 2 is. And assume that I only have Cayley diagrams to work with. I have nothing else, no other knowledge about what this mysterious 3 times 2 is, I should say, in our group, which is this mod 5 arithmetic. I can do something like what I did over here. There are 2, well, there are at least 2 ways. Okay, let me write down one way. I can start at 2, and I can follow a 3 arrow. Another way is that I could start at 3 and I could follow a 2 arrow since I'm taking 3 times 2 is equal to 2 times 3, since this group is abelian, or the operation is commutative. Now this second one corresponds to 3 times 2, and the first one corresponds to 2 times 3, if the group is not commutative. But in any case, now what would the second one look like? Well, the second one, I'm on the same Cayley diagram, but now I need to introduce some 2 arrows. So what do 2 arrows look like in my group? Well, they would look something like this. And then 2 times 4 is 8. And 2 times 3 is 6, which is 1. Okay, so if I start off at my 3 and I follow a 2 arrow, I start at 3, I follow this 2 arrow, I get back to 1 as well. Okay, I get the same thing as when I started at 2 and I followed the 3 arrow to get 1. What I'm really doing all the way along is I'm starting at the identity. I'm following a 3 arrow and then a 2 arrow. Or I'm starting at the identity. I'm following a 2 arrow and then a 3 arrow. Okay. So these are all different ways to use a really simple Cayley diagram to view pretty simple arithmetic. Of course, we can do the same thing with more complicated groups, but one of the key things that I want you to see here is this difference between viewing this as an action versus a binary operation. And what is acting versus what is not acting is a key difference in perspective, but we end up getting the exact same thing. But this perspective or just subtle way of thinking about it really influences how we view the group and the things that we can do with the group. So make sure that as you keep seeing groups in terms of binary operations, that you don't lose this action perspective, because the action perspective is what you're going to need to delve really deep into groups.